So this is what is done for milestone 1, and my name is Bipatran, and here's what I've done. So starting off, let me show you the singleton, and I get a game object. Yeah, the sprite box manager is created only once, and afterwards it is being used by the game object to create different sprite boxes around it. And I'll show more of it in demo. Just a minute. Yeah, here it is. Yeah, as you can as you can see, initially when the sprite box manager is created, and when it is created, an instance of it, is being checked to see if the is null. If it is null, it means that it has not been initialized yet, and a new instance is initialized. If it has already been initialized, then nothing happens. And finally, to destroy the singleton, the instance has been set to null, and this is what's done for the singleton. Moving on, we see the factory. So to create the aliens, I use the factory, and it uses a switch case. Like later, this will be switched to flyweights. And I'm using three types of aliens: a crab, a octopus, and a squid. And so a game object is created which takes in the sprite name and the position of x and y, and accordingly it's being created, and laterward it's being pushed to the game object node, because the game object node is responsible for the updation, and also like it's being pushed to the sprite patch also, because like sprite patch is responsible for the draw. Moving on, we have the object pooling, and object pooling, the rest I'll show it in the demo later, how the full thing. But going on, as per the specification, an image manager is creating a PO active and a PO reserve. And initially, the number of reserved is 1 with the delta grow of 1, like it has been set according to the PDF. And I'll show that it is working perfectly in the demo. Now we have the priority queue. Priority queue is been implemented twice in this right now, twice. One is in the sprite batch manager, and next is in the timer timer commands. So I'll show both of this. So in the sprite batch, I included a command called add sort, and here it's here that you can see that, I mean, it's taking a key. That key is the key is being passed as a parameter for the sprite batch manager. So with this, we can determine like which should be drawn first and which should be drawn last, like according to the. For now, like I only put in once, but during previous iteration, the working demo is shown already, and this is the key. The same thing is used also for the timer commands. Going down, we have the timer commands, and here you can see that the timing is taken as the key. The delta time is taken as the key. I mean the delta time is not taken as the key, but delta time is given as the parameter, and with that the trigger time is calculated by getting the current time and adding it to the delta time, and that is being taken as a key for doing the priority queue. 1 minute, I'll also show that. Yeah, Here you can see that the trigger time is the current time plus the delta time to trigger, which has been passed, and with that we are calculating the trigger time and passing it using to the b add sort, the same which are used in the sprite batch, and it is being done in the parent class. The working demo will be shown soon. And we also have the proxy. The proxy is quite simple. Like only right now I'm just passing in the x and y, like, and then I'm finding the real sprite, and when update is called, the x and y value is pushed to the real sprite, and it's being updated and rendered. Iterate. So for the iterators, I have like two iterators. One is the d-link iterator, and the second one is the s-link iterator. The d-link iterator ensures that it moves from. I mean, the manager movement take place perfectly, and I am using the s-link iterator for doing the animation. Uh, Here you can see that we have an s-link and s-link iterator. This is to ensure ensure that the sprite animation, it like every time the animation command is called, it just the in the s-link there is the different images, and it moves to the next image, next image, and then we pass that image back to the sprite, and that's how the animation is being displayed. So now we have the template pattern. Template pattern, it's mainly like used in the managers. For example, in the manager class, we have like yeah, all these three functions are example of the template class. Here, like we are using this create node, but the create node is being defined in the child class, because like each child, they have to create their own they have their own specification kind of stuff, so that we cannot do this in the parent class, and it has been passed to the child class. And this is here the compact keys is also like an abstract class that's been done in the child class and being used in the parent class, and this is an example of the template pattern. Composite pattern, like we have the leaf, the leaf composite, and that is being used for the especially for the movement, and later on it will also be like used for the collision. Right now we are creating a big grid, uh, and in that we are adding declaring, I mean, in that we are initializing columns, and inside that columns we are adding game object, and that game object, I mean, even the alien grid are game objects, but like we are adding the game object which has the sprites in them. uh, as you can notice, these sprites are leaves, and they have like no child. And the main purpose we are using composite for now is to move them, like move the whole thing uniformly. So the movement, for the movement, the composite pattern is used so that all of them can move uniformly. Adapter and game objects, like just for the initially, like when you are declaring the game object node, we are initially like pushing in a null game object, which will That will also be shown. Sorry, wrong one. Yeah, initially, like when we are declaring when you are declaring the node manager, like initially we are pointing the game object node to be the game null object. Right now it has been used for this, but later on it has like different purposes which will be done for future sprints. And finally we have the adapter pattern, and for that, going to the texture, we that this texture acts as a wrapper class, and after all the things has been done, all the changes finally is being pushed to the azul texture. So this is the adapter class being used, in which like all the changes done to the texture when it's fine is being finally pushed to the new azul texture. And that's for the explanation. And this is the demo being shown. Like initially you can see that uh, the okay, I mean, let me explain. So for the sprite box manager, we have this for the singletons, we have the sprite box manager, and as you can see, I have drawn the sprite box across alien, each aliens, and also you can see that the animation command is working perfectly, by which you can see that the image is changing every 0.5 seconds, and also you can see that the whole thing is moving in a discrete manner, and this is proof that the movement animation is working, and the whole thing is moving is done due to it being included inside a grid. And this is the composite pattern. We are doing the animation movement animation using the composite pattern, and that's what causing it to move. And and if you saw, and for the object pooling, like I'll run it again. Initially you will see that uh, the bird is not the animation for the bird is not happening. Or I'll stop. Yeah, I stopped it. Yeah. And yeah, initially you see that the animation is different, and suddenly it's switching to the bird. This is the object pooling, in which like I after two 200 I mean 200 times the update is called, like it will be replaced with a bird instead of the green sprites. And this is to show that the object pooling is working as intended. And with that, all things have been completed for milestone 1.